Okay, so we have a 7,000 seat theater, and it has tickets for sale at $30 and $49. And we're asked to find out how many tickets need to be sold at each price for sellout performance to generate a total of 256,075. Okay, so the first thing I notice about this problem is that they're asking about two different numbers. They're asking about ticket quantity versus revenue generated. Okay, so for ticket quantity, we know that there's a total amount of 7,000 seats, and that we have two types of tickets. So what we're going to need to do is set up variables for each type of ticket. We have a low cost, the cheap seats, and we have the higher cost, expensive seats. So why don't we just go ahead and make those X and Y, where X is equal to the number of cheap seat ticks sold. We know it's $30 each, and Y is going to be the number of expensive seats. So with that, then we know, because we only have 7,000 seats, that X plus Y has to be equal to 7,000. It has to be less than 7,000, but then we also know that it has to be a sellout performance. So we know that it actually equals 7,000. So that's our first equation. Second equation then is we have to ask how much are we going to generate every time that we sell a ticket. So in this case, every time that we sell a cheap ticket, we're going to get $30. If you sell one, then you're going to get 30. If you sell two, you're going to get 60. If you sell 10, you're going to get 300. So the formula that we need here to capture the revenue generated by the cheap seat tickets sold is going to be 30x. 30 times whatever number of the tickets sold of the cheap seats. It's going to give us the amount of revenue for that. And then we're going to also need to account for the number of expensive tickets as well that we sell at $49 each again. So it's 49 times 1 if we only sell one. It's 49 times 2 if you sell two tickets, so that would be 98. You sell 10 tickets, it's going to be 490. So the bottom line is this number here is going to tell you how much that you've actually generated given the number of tickets that you've sold of the cheap seat tickets and the expensive seat tickets. The missing piece of information that we need then is right here, because we know that the revenue has to end up equaling 256,075, and that is our second equation. Okay, so now we've gotten the setup of the problem out of the way. Right now, and that was probably the difficult problem, difficult part of the problem. Here is now we're just moving to the algebra. You have a system of linear equations, two equations and two unknowns. There's a bunch of different ways you can solve it, but typically when you have something that has like an x or a y that's already has no coefficients, the most straightforward way to approach it is through the substitution method. So that's what we'll do here. in the substitution method, what it involves is taking one of the equations and just solving it for one of the variables. So in this case, we have x plus equals 7,000. So let's say subtract y from each side, and x equals 7,000 minus y. We take this guy now and plug him in right over here. And that gives us and just using the standard algebra techniques, we have to distribute the 30. So that's going to give us 210,000 minus 30y is 49y is 256,075. Just regrouping these things here, let's 19y plus 210,000 equals 256,075. Subtract 210. 19y is equal to, what is that, 46,075. We can bring up a calculator to help us here. That looks like 46,075 divided by 19. It's going to be 24. 2425. That is the number of expensive seat tickets, and from here what we need to do then is just plug this back in to this guy right over here. X equals 7,000 minus y, 7,000 minus 2425, and let's bring the calculator back up. 4575. So, and then just to check them, question is we get 4575 up here, 2425 there, and when you add them together, do you get 7,000? Let's find out. 4575 plus 2425, and indeed we do. Question is down here is if we do 30 times 4575, and where do we go when we do that? Let's just do that one real quick. 30 times 4575, so 137, 250. That's the amount of revenue that's generated by the cheap seats. And then we do the same thing over here. 49 times 2425. It's 118,000. 825. The question is, when you add them together, 137,250 again, 137. O plus 118, 825, lo and behold, equal to 156,075, which is what we're looking for. So our answer is, how many tickets should be sold at each price? We need 4,575. And 24.25 at 49. Thanks for watching.